Hello and welcome to everybody to our today's training according AFAM 6 for students. My name is Juliane Stopper. I will today give this presentation to you. I'm working in the Lubal team on the one hand for customer support and on the other hand I'm supporting development teams for concrete design and geotechnical analysis add-on. Yeah, and we have Walter Fröhlich with us, my colleague. You can introduce yourself, Walter, please.
Thank you. Hi, my name is Walter. At Lubal, I'm responsible for the customer support via phone, email, and chat. And furthermore, I'm also responsible for the development of the add-on steel joints. Today, I will answer to your questions in the chat.
Okay, that shall be enough for us, according us. We will now go into the presentation and therefore switch our cameras off. Yeah. So let's go on. Yes, first slide is an organizational thing. You have from GoToTraining this panel where you can use this button for hiding or showing the panel. If you want to see the full screen, you can hide it. And if you should have problems with the audio settings, you can go to the sound check and check whether maybe it's connected with some settings there. Yes, and you have the chat. As Walter said, you can there enter your questions either to the whole group or directly to Walter, and he will reply all of your questions. And don't worry if there should be an open question at the end of the presentation. We will answer this afterward. You will receive an email and we will not leave any question open. Yeah. That's enough for this. We can go to the next. Yeah, today's training is part of the training series for AFAM 6 for students, and we are in the 5th part and the concrete design. So today, concrete design is our topic. And we therefore will have a look at a first introductory example, a concrete beam, and then we will also work on the design of a concrete slab. Yes, and I think that's it. Yeah, this will be the slab. Then we can go to the program. We do see here the AFAM 6, and I open a new model via this button here on the left side, and therefore the base data will open. And there we can give our model a name. I call it A concrete beam, and this is enough for this fields. We will go to the add-ons to this register, and here we will activate our concrete design add-on. So our main program is for finite element analysis for a structure. So you can give a structure with load and supports, and you will receive internal forces, stresses, strain, and displacements. And if you choose any add-on here, this main program will be enlarged by the settings you need for the add-on you want to have. So now we will have input and calculations and also results for concrete design in the main program integrated. And with activation of the concrete design add-on, you will also have here in the standards the option to set the standard according to which you want to do your design. So I leave this today. We will do our design with according to Eurocode, but you can also change it here, as you can see. Okay, for the other topics, no further settings are needed for our first example. So I say okay, and our first empty model is prepared. Okay, so this is now our model. It's empty. AFAM 6 is organized like this. You have some two materials, some section. It depends on the model you had before. The program keeps in mind which materials you used and proposes these materials again. But I want to start with you from scratch, and therefore we delete all basic objects. We want to do it without any proposals. But later, if you do similar models, it can be helpful if the program keeps in mind your last settings. Okay, so now here we have the navigator for data, and I find it comfortable to go in this row and fill what we need. So the first point is materials, and we go to create two materials. The first material I want to create is a concrete, and I can do it manually. I can set here the material properties, but I also have a library. With this book button, I can reach the library, and I want to have the European Union as region, and as material type I set concrete, and then it's more easy for me to find what I was searching for. I want a C3037 as concrete, and I say okay, agree, and now I have it here. I say apply, and then I can see that it is in my model. What I should do too is, if I want to use the concrete design, I should always directly create a material for the steel, for the reinforcement steel. So I will create a new material, and you can also, if you know the name of your material, you can directly enter it here. So I say I want B500, and I want to use B500SB according to Eurocode. It's important that you select a material which standard fits to the standard you entered in the base data that you want to do your design for. So you shouldn't say that you want to make a design for ACI and use Eurocode material. This is not working. So now we have our concrete and our steel, and I just entered the name, but the program took from the library for this name the material properties. So we say okay, and I have my two materials here. Then we can go to the next point, to the sections, and I want to create a new section. And here I also have a library. You can see here several options, and I have some cross sections directly here, which is comfortable when you want to do a concrete section. These are often used and therefore here placed here. Here's the material assigned. It's right. We want our concrete for this cross section, and we will have a beam that has 300 millimeters as width and 450 millimeters as height. Okay, and I do apply this, then it also came up here. Okay. Yeah, we have different colors for the names of the properties. If it is blue, it means that it is defined in the model, but it is not used by the model. And if it is black, it is defined and used. So, my concrete became black because my cross section uses this concrete. This can be helpful sometimes to control your model. If you somehow see a material that you actually did want to use and it is still blue, you can check where you forgot it. Okay. Then we have everything prepared to create our beam, and therefore I want to use this button here. We have a new single member, and here the dialog for the member opens, and we have the first setting we have to do is the member type, and we have a beam as default setting, and you have several other types you can select, for example rigid or truss so that only normal forces are transferred. But we want to have a beam now. And the program understood that you have a concrete cross-section assigned, and therefore here design properties are activated because we activated the concrete design add-on. And yeah, this is how the dialog looks if you don't use, you don't want to do the concrete design for this member. If you want to do it, you have to activate this and enter the data that is needed, but we will come to the design properties later. Okay, the second register of the member is the section, and here we see that we have at member start our cross-section number 1 assigned, and for member end it's the same member as the same section as for member start. And here you can have other distribution types like linear or something, but we want to have a uniform beam for this example. I say okay. And now I can graphically create my concrete member. Therefore, I click here on this point and I want to have a beam which is 8 meters long. So I use my grid and I finished my beam. I did click there. And now I want to leave this. I don't want to create new members. I can do a right click and then I left this option. And this is my member created here. I can do also this. We have here the 3 types of views. We can see wireframe model, solid model, or transparent, and I want to show the wireframe now. The next thing I want to enter is the support. We create a nodal support here. Therefore, I do a right click on the node and I say edit node. And here I have the option to assign a support. And then a register for supports opens and I can use one of them that is already here. And I want a fixed one for this node. And I have it here. The second one I want to have within the beam. Therefore, I do create another node. I can go here on members and say divide member, and I want to do it at distance. And I can say 6 meters from member start, and automatically it fills 2 meters from member end. And I want to use this setting here, create on member nodes without dividing the member. Yeah. Now I have a node here, but my member is not divided. It's treated like one beam. This influences the concrete, the reinforcement, the concrete design, and so on. So now I can put here at this support, at this node, my next support. So you have again, for this node, I also have this option to go on support. And now I want a roller in X direction. And with this button here, I can have a look at this support also. I can edit it. And for this type, I want to do it. The dialog opens. And I want to also fix this rotation around X, and the other settings are fine for me. I say okay. Okay. And I have my supports created. Okay. Then I have prepared everything for the beam. The only thing that is needed are the loads. So I go to the loads. We have here this folder, load cases and combinations. I do a click on it. And the first base register that I see shows me again which standards were selected in the base data. And I can see that I have a combination wizard active. The combination wizard generates load combinations according to the standard that were set. We will have a look at this. So if it's switched off, you only can manually define load combinations. If it is switched on, you can define them manually, but also you can generate them. Okay, let's go to load cases. yeah, we have one first load case prepared. It's the self-wait load case. We can see on the right side that the self-wait is active for this load case. And we create another load case that is live load field 1. And it needs another action category. It's important to take care of these. It's important for the combinations, for the automatic generation. And I want to have the category B for office areas assigned in this model. And I do a copy of it because I want to have another live load here. Okay, then I can apply this too. Other settings are not needed, so I can go to next register. Here I can see the action categories that I have in my model. I have permanent and imposed loads, which is fine. Then I can go to design situations, and here we have the design situation type. These are available, and with a click on this eye here, you can see according to which rule the generation of the combinations is done. And you can also see that this ultimate limit state design situation is active for the concrete design, so it will be used there. And we have a combination wizard here active, which is also needed if we want to generate these combinations. And we see that with this wizard, load combinations are generated with static analysis settings with second order, according second order. And we don't need imperfection cases now, so we can switch it off, but the rest is fine. Yeah, and we have one characteristic combination, frequent and quasi-permanent, and they are currently all active for concrete design. So here we can see how the different action categories of my model are combined, and then finally the load combinations. So these are generated, and this is fine for my model. Okay, then we have to fill the loads. We have them prepared, the cases, but we have to define the loads also. Therefore, we have here a folder loads, and these load folders, the specific, were created after I did define these cases. And I have now a folder for self-wait, and I have to fill this. The self-wait is already existent as I activated it, and it's calculated automatically with the material's specific weight and the cross-section. And you can have a look at it. We have in Navigator Display where you can find the settings for the display, and you can find here a setting to switch on the self-weight, and you can see what the program automatically calculated, and you can compare it with what you expect. Okay, I want now to add a self-weight, a load in the self-weight load case. And for assigning a load on this member, I have here this option, this button, to define a member load. I use the self-weight first, the self-weight load case, and the dialog opens. So here I can define member loads. Currently, I'm defining for self-weight load case. I want to define it for member number 1, and I want to have 1.5 kilonewton per meter added. I say apply and next, and then I can see it. Yeah, it was added. If I would press OK, this dialog would close. If I say apply and next, it's assigned, and I can use this dialog for the next load. You see now I'm in load number 2, and now I want to change the load case. I want to define the live load for field 1. Again, I take member 1, and I have here the options to define a trapezoidal load, and I want to use 20 kilonewton per meter for both values, and I use from 0 to 6. Okay, and I again say apply and next, and then I can see here for my load case number 2 it is assigned. And now I go to, it didn't work somehow. I'm still in the load case 2, so I cancel it and I create a new one here. Don't know what I have done. Okay, I create a new member load for member number 1, and now I want to have it at distance 6 till distance 8. Okay, now I have it here. So I have these load cases, and I also can have a look at the combination. Yeah, if you go to a combination, you can see how it is combined, also the result of the loads with the factors, safety factors. Okay, now we have finished all the input that is needed for doing the static analysis. With this system and its loads, you can calculate the inner forces of the system and the displacements. But we will now have a look at the settings that we need for concrete design, which is our aim today. Maybe shortly before we do this, I only want to tell that we have here also this these tables, and here you can find all the settings we did again, but in a tabular form. This can sometimes also be useful to work with the tables. Here, for example, we are in the list of materials. Later we will go here too. Okay, whoops, I want to make it smaller, this bit bigger, and now we can go to the reinforcement. For the members, I can do double click on the member, and then I come back to the member dialog, and now we want to look at the design properties. So the first setting that comes from concrete design is the concrete effective length. This setting you only need to do if you want to do the equivalent member method for stability design for members. So for members that need this. In our example, we don't have a stability problem. We don't need to assign an effective length. Then we can go to next register. Here we see the concrete cover. We have concrete durability, and we can have a look at this also. Here we have a graphic that helps us. It gives an overview for the parts of the structure and which exposure class could be fit for this part of the structure. We have now here XC1. You can also select other ones, and if you need other settings, you can edit. And here you also have special concrete cover options. Okay, we keep the standard settings, and the program automatically calculates this CNOM of 20 mm for our member. You can edit this. You can do a user-defined value, and you can also define it different for different sides of the section. And also you can assign different if only one has another exposure class, for example, but we keep the standard setting. Okay, then we go to shear reinforcement. Here we have at first the setting of the stirrup type. We can choose, you can, for example, choose a 4-legged stirrup, but we want to keep the 2-legged, the standard. And here we have the reinforcement steel automatically filled. This is what is done if you right at the beginning create this reinforcement steel. Then it's automatically filled in the first reinforcement settings. If you haven't defined it before, it's no problem. You can also define it later, but then you manually have to go to this reinforcement dialog and here select your material. But now it's here automatically. I want to change the bar diameter to 8, and I want to also change the distance to be more narrow. Yeah, you can also define different fields within the beam. If you want to have one zone which has a more narrow stirrup reinforcement or more wide in the center, this can be done. Then we can go to longitudinal reinforcement. Here we have also different types. We have symmetrical rebar type, unsymmetrical, uniformly surrounding, which is good for columns, for example, and you can add lines or singles. We want to use unsymmetrical. We do at the top side, we will do 3 bars of 14 millimeter diameter. You can add these center bars. I don't want to use them in this model, and I want to keep the 3/20 at the bottom. Okay, this can be applied. And I have design configurations. Here I have ultimate configurations and serviceability configurations. If we open those, we get here a dialog where you can do all the settings according to the standard you chose. There are different rules and you can assign them or not use them. You can define whether you want to have minimum reinforcements included or you only want to see the result of the forces. You can say if you want the reduction of shear forces active at support phase and distance D. Yeah, different settings. Shear joint, you can, for example, have the check for it. We don't want this in the model now. Yeah, this has to be looked at once and then it's fine. The same thing or analog thing for serviceability configurations. And then we have one last register that we have to look at, which is according the deflections. And here we have to define design support, which gives information about the dimensions of the support. And this is needed for the design checks. Therefore, design support. We create a new one here. We have it active and we want a width, which is in this direction, of maybe 300. We keep the setting and we can say that the support depth in this direction is taken by the section width of the member. Yeah, and I say my first support is a monolithic connection and no inner support, and is active for deflection but not in the Y axis. So this is assigned here and we can see it here at the member. And now what I need is a second design support at this node because it's supported and this node is an internal node and therefore I have to define it here. And I create a new design support for it as it has different settings. It is an inner support. It shall have no monolithic connection and the rest we keep. And then it looks like this. This information is, for example, also need to be known if you want to reduce the shear force at distance D from the support phase. Yeah. Okay, so now we have this. And our beam is prepared. One thing I wanted to show, one last thing. If you are in the reinforcement, you can also use this button here. This gives a nice overview about the reinforcement for this member. It can be more complicated if you have some additional reinforcement. You can also add reinforcement shorter. We will do this later. And then you also can print from here. You can print to printer, to PDF, or to report, different options you have. Okay. Now we should have enough for the design. We can now solve this model. Therefore, I want to go to the table. We have here in the table also at the bottom the concrete design. And here you can define input data. For example, I don't want to have this design situation solved now. And then you can have a look here. Yeah, we have only one member. And we can start the design. I press on this button and the design is started. And now the program, what the program does is at first you get a mesh, and then the program calculates all the load combinations that belong to a design situation that shall be considered in a concrete design. So now I have here ultimate limit state, characteristic, and quasi-permanent design situation.
Juliane, I have a short request.
Yes, please.
Could you set me please as moderator in GoToWebinar, because I can't see any questions. I don't have that field.
No problem. I will have a try. Can you tell me how? I can see you.
Yeah, and you have to click with the right mouse button
Right click
on my name and set me as moderator or something else.
Ah, yes, I found it.
Moderator.
Okay. Should be working now.
Actually, I still don't see any questions or the field for the question.
Yeah, I don't see the field also, but in the chat I also don't see something.
No, because questions from participants will be shown in the tab questions and not in the chat.
Yeah, I don't see this also.
If there will be any questions, we have to take a look into it later, and you will get the answer via email. Actually, I can't answer anything. Okay.
Okay, sorry for that. I don't see anything.
No, I think it was a mistake from I think from Luisa. I think she did something wrong there.
Okay. Do you see it now, Walter?
No.
Okay. Do you see my screen?
No.
Still? No?
No, I got a question if I want to share my screen. Wait a moment.
Maybe you have to give me back the.
Yeah.
I have to. Yes, I took it. I took it.
Let us proceed, and the question will be answered via email.
Okay, I will go on. In the meantime, the program finished its calculation and we see the results. Here we have, we can do this. The first, what is shown is an overview about the design results, and it's generally looking a bit red because it shows you the problems you have in your model. But when you go on design ratios on members, you can see all the checks that are done for your model, and you can see that it's not so bad. A lot of green is there too. So all these checks were done by the program. And you have here on this right side the option to deselect design checks in the overview. They are there, but they are not shown. For example, we have also detailing checks that are not the most important checks. I mean, they are important, but not as much as ultimate limit state, for example. And you can just hide them for now and look at the main checks. And now I can see that I have a problem in my ultimate limit state check in the section resistance, and I can have a look at this more in detail. And I also can see it here. I don't want to see now the loads anymore. I just want to see my member, and I also can remove the reinforcement. I therefore have this button here, and now I see my member. Maybe this is also nice. No, it's the best like this. And I see the results. I see now an envelope, which I don't want now, you have always the option to see results of the design checks and of the reinforcement. And I now want to have a first look on the design checks. I go to ultimate limit state and I check my UL 100. That is here shown as red, which is for the cross section. And I can see in this area my load is too high or my cross section is not strong enough with this reinforcement. And here we have this fixed support, and we can imagine that there is some high moment here from the support, and it could be a problem with the longitudinal reinforcement at the top side. And this now we can check. We can have a look at the reinforcement. I now deactivate the design checks, go to reinforcement, and I want at first to see the required reinforcement for the top and for the bottom side. This is what the program calculated with all the checks that were done as required. And then I can have a look at what I have provided. And I can see on the bottom side I have enough. On the top side here I have a problem. And this fits to my to the idea that it comes from this support, support moment here. So we can add here some reinforcement, and we also have the options not only to look at the required and provided values, we can also look at the not covered reinforcement at the top and at the bottom. At the bottom we see it's 0. At the top we can see that 4.82 is needed to make this work. Okay, then we will add reinforcement. Therefore, I double click on the member and I directly go to longitudinal reinforcement, and I can here add in this area new rebars. Therefore, I click on new item and I want to use unsymmetrical, and I set bottom to 0, and I add here, I want to try those. Maybe 3 or 14 are enough. No, I need 4.82. Therefore, I add 3 of 16. Okay, yeah, you always can here see the calculated reinforcement area, which is quite helpful. So these I want to add, and I don't want to add them along the whole beam. I want to add them in the locations between 0 and maybe 1.50 meter. Let's have a look. Yeah, maybe we take 2 meter for covering the need. Okay, then now it's placed at the same position as our top reinforcement. Therefore, I want to set a reinforcement offset. I say from stirrup, and top side I have again 30 more distance, and now it's fine. I say okay, and now I can also again have a look at this, and I see it's added to my print preview. Just nice. I say okay, and now I can do my concrete design again. Okay, and now we are in the view that we have the not covered reinforcement active for top and bottom, and we see nothing is not covered. Our UL 100 is now fulfilled with this reinforcement. What you also can do is you can look at design checks in detail. For example, I want to show the UL 200, which is also important, which is the check for the shear resistance, and it's fulfilled, and we can see we could even reduce shear reinforcement as we have 60% used of the resistance. And you can also do a double click on every design check. You can do a double click on this name of the design check, and you come to design check details. And here you can follow all the check details. You can see what is done in the background. You can see why why it's not fulfilled, or which is a value that has a bigger influence. Where's the problem? You can analyze it here more in detail. You can even, if you want to see more clear what is done, remove the values and just look at the formulas which are used in the background, and then again see it with the values of your structure. And you can open things in detail and follow it. And I want to also show this button. Here you can have a look at your cross section and see the stress state, and we can see we are now at member location 0, which is member start, close to the fixed support. And we see here we have tension at the bottom top side, and at the bottom side we have compression, and our concrete is in compression too. Yeah, okay. That's enough for this, I think. I would like to now go to the next example. We have the beam finished, I think, yeah. Okay, then we go to the next model. I shortly have to open this. I have prepared a model I want to show you in the slide. We want to model this structure. We have a reinforced concrete slab, which is based on walls and columns, and it has also beams here. Yeah, at that part of the slab that are not supported by walls. Okay, and yeah, we will have C37 again, and the rest we will have a look at in the model I will show there. This is the aim, but we are interested in the slab mainly. So we go back to the model. This model I did prepare so that we don't lose time with creating the geometry. I want to show some characteristics of this model, and then we will do the reinforcement and the design. Yeah, so here we have the slab, and we have here these special beams I want to show. We have members, and these members are of type rib. So they are working like this. They are working together with the slab, and we have a special rib register here where you can enter rib information for the effective width. Yeah, and here you have a preview. What I can see now is I don't have design properties here provided. This means I don't have my concrete add-on active. Therefore, I go to base data, set my concrete add-on active, and also again check the standard. Oh, I want this. And I say okay. Okay. So now I have my rib here. Then I have here at these lines I have walls, and we have now the situation that we are interested in the design of the slab. I am not interested in the design of the walls or the columns in this problem. Therefore, we have a special feature which allows you to keep the model more simple. We have a special line support, and we go to this support. We can see here in the types for nodes, we can see nodal supports, and also types for lines, we can see line supports. The black one is used, therefore I do a double click on the black one. So I see it's the one that is used in the model. And now I want to show this special line support type, we have the option to define the stiffness of the support via fictitious wall. Therefore, a second register opens, and here I can enter the values of my wall, the characteristic, the height and the thickness, and also the material, and the program calculates an equivalent stiffness and automatically fills these stiffnesses here. So this is what is used for the walls, and also we have the pendant for the nodes. We can go here and can also show that we have here the stiffness via fictitious wall column. Yeah, so here we have the similar. We can enter the dimensions, the height, the hinges, and material, and automatically the stiffness is calculated and filled in here. Okay, and we can also, in the navigator for display, we can activate that we can see this special thing. We can go here on line supports and we can activate the walls, and for types of nodes we can also activate the columns, activate, and now we can see which kind of supports are assigned here. Okay, and I can in the members also activate the rib section. Then I can see the width that is considered in the rib. And what you can do also is you can go to rendering and activate that for your surface. It is considered filled and with thickness included. So you can now more realistic see how your model is working. You have here the thickness of your slab, and you have the rib, which is directly connected. Okay, let's go to this view. So this is the model. I want to shortly show the loads. I have to go to them also because I changed the standard. The action category is lost. I set here imposed load. Yeah, okay. And we can have a look at the load. I have an imposed load and a self-weight active in this model. Okay, and now we want to do the reinforcement. Therefore, I double click on the surface and I get into the dialog for that surface. And here I have also the design properties equivalent to the members settings. And there again, you can find the concrete cover settings. Yeah, you can again here select the exposure class. Then you have a new register here for where you can define the first direction of the reinforcement. Shall it be X direction or Y or rotated? We keep the default setting. If you want to set it, you can use this button here in the middle. Then let's go to the surface reinforcement. We can see that it is not reinforced yet. We want to define a surface reinforcement. And the dialog opens for our reinforcement, and we have the location type on surface as default setting active. This means for all of the surface, independent of the geometry, for all of the surface, the reinforcement is assigned. We have as reinforcement type the rebar, and our material is again automatically found. And we activate that we want to have the rebars in both directions, and I want to have 8 every 15 centimeters, and I want to have this reinforcement for the top side. And I can say apply, and now I do a copy of this, and I want to set the reinforcement for the bottom side, and here I use 10. Okay, I say okay. And here also we have the design configurations and the deflection settings. I keep the standard here. So I can also go to my navigator for display, and then activate the types for concrete, then I can see that I now have a surface reinforcement. We don't see a reinforcement in the ribs because I didn't reinforce them. I'm now interested in my slab here. Okay, I want to collapse this to get an overview. What I wanted to show is that from concrete design, you have here this folder types for concrete design. And here you can find these settings. You can find the concrete durabilities that you have in your model, reinforcement directions, and the surface reinforcements. So here you always have an overview of all surface reinforcements of your model. And then you here have a concrete design folder. If you do a right click on it, you have global settings for the concrete design. And there you can activate which checks you want to do. And for example, I now in my model don't want to do serviceability checks. I only want to see ultimate results, and I don't want to do fatigue checks. So I activate only ultimate. I say OK. And then I see also only the configurations for ultimate limit state. And these are the same configurations that I opened, or it's the same location that you can open if you go on the member or on the surface. You can also find them here collected. In the concrete design folder, you find the configurations. And here again, we have all these settings I did show you for the beam example. Okay, so now we have prepared everything and we can go here. I want to deactivate them and only solve the surface, and then I start the design. Now only the ultimate limit state combination is calculated, because only this was active as design situation for the concrete design. Okay, now again we have this overview here. And we can have a look on design ratios on surfaces. And there I can see I have here some much too high design check ratios. And we can have a look at those. It's in the ultimate limit state, and it's the longitudinal reinforcement in the first and second direction for the top side. So we can have a look at this, and I will use isobands. It's more easy to see for us, and we also will hide the surface reinforcement. Okay, and go to this view. So now we see that above the supports we have these too high values, and it's similar to the problem in the beam before. It's at the support we have too much tension on the top side, and therefore we have not enough longitudinal reinforcement at the top side. If we look in the other direction, it's similar, and now we can look at the bottom side. And here we can see that we have the highest ratios in the fields, which fits. It's the bottom side of the slab, but it's all below 1, so it's fine for the bottom side. So what we need at the top side is some additional reinforcement. I shortly want to present this to you also. We can directly go here and say we want to define a new surface reinforcement. Now we want to have a free rectangular type, and we assign 10 every 15. Let's have a look. I will take 16 at every 15. Okay, and I say okay. I have to, of course, define the position and the surface I want to assign it at. And I use this position here. And I take 2 meters in the A direction and 2 meters in the B direction, and I say OK. And now I can see that I have some additional reinforcement here. And if I select it and I press the control button, I also can, with drag and drop, copy this reinforcement. And can copy this here also, these two. Okay, this shall be enough because of time. We have to, of course, copy it here as well, where we have too much. And I want to start the design again. You can do it like I showed for all the locations where the values are not fulfilled or you need the additional reinforcement. Okay, let's check the top side. I want to remove the reinforcement from the view, and we can see it improved, but maybe not enough. We can also look at the reinforcement directly. For the top side, we can again go to the not covered reinforcement. Then it's more easy to see what is needed. So we see here at these locations I didn't put additional reinforcement, so there's something more needed. But here these locations are now fine. So if you would copy it there too, it would be fine too. Okay, that's enough for this. I think we can maybe go here to this design check results. And I want to show you other display types. You can select the isolines as I had active before. This can be useful for printing the results. And we also have values on surfaces that you can use. Yeah, and like this, it's more easy to print. You can have a look at these settings here. So here below, you can find settings for the display of results. Yeah, like this. Something else? No, I think it's so far fine as introduction into the concrete design in RFAM 6. Yeah, something else? No. You here also for surfaces can have a look in design check details. Maybe we can have a look at this once. And you can follow the formulas even for surfaces. It's all clear here, no black box. You can find what is done and analyze it. Okay. Yeah. So then I would finish now. I hope this gave you a good introduction into the concrete design in RFAM 6. I now want to shortly go to our homepage to show some more things. We have our homepage www.glubal.com where you can find a lot of stuff for learning. You can download a free license for students here. You just have to fill the forms and then you can receive a free student's license. And we also have here support and learning stuff. You can see the videos here in these videos. The recording of our today's training will also be found. We have webinars, we have knowledge base articles. I did open this, and you can enter the keywords or text you are searching for, and you will find more quite information, a lot of information for different topics according, for example, the concrete design. Yeah, like this. And we have also models to download, which can be helpful. And we have manuals where you can have a look at the concrete manual, for example, if we think of today's topic. Okay, then I came to the end for today. Thank you very much for your participation. I wish you much joy with our software. And if you should have questions, you can contact our support. Here we can see it via email. Yeah, have a nice evening. Thank you for your participation. Bye-bye.